Okay, so let's do a quick review. In the last lesson, we introduced the idea of our quadratic relation in vertex form, which is what we see here. Y is equal to a times x minus h squared plus k. So this is what we called vertex form. And the reason why we called it vertex form is that eventually we're going to learn, as in today, that we'll be able to pull out the vertex of our quadratic relation simply by looking at the equation itself. That's the idea. Now, last lesson, in 4.3, we learned what the a value represented. Now, we started off by introducing you to the parent relation, which is the simplest form of a parabola, simplest form of a quadratic relation, y is equal to x squared. And when we graphed that, we saw that it very neatly balanced around the y-axis, and everything grew, like all the y components grew at an exponential basis. There was no weirdness going on or anything like that. It was just a simple curve. So what did the a value do? Well, the a value told us two things. The first thing it told us was if it was a negative value, it told us that it would reflect the entire parent equation, the parent relation, in the x-axis. So if a was negative, then it would reflect, it would reflect the entire relation in the x-axis. So as it says here, previously the value a transformed the graph y is equal to x squared by reflecting in the x-axis. But again, only if a was negative. The next thing it told us was how much is it going to stretch or compress the graph vertically. So imagine you grabbed a hold of one of the points on the y is equal to x squared relation, and you either stretched it by pulling it up or you compressed it by pushing it down. And that's what we mean by vertically stretching or compressing. Stretching, or compressing. Now, how do we know which is which? Well, we learned about absolute value, and we learned that if the absolute value of a is greater than 1, then it is stretched. If the absolute value of a is between 0 and 1, so if 0 is less than the absolute value of a, and the absolute value of a is less than 1, so if a is between 0 and 1, then it was compressed. Great. So what about these guys, these h and k? Well, that's what the focus of today's lesson is. We're going to learn how do these variables affect the overall graphed result. So the h and k, what they are, those are actually the coordinates of your vertex. Oh, that's great news. Now there's a catch here. You have to pay close attention to the actual equation itself, because if you look at the equation, it says a times x minus h. It's only the h that we care about. So that minus sign, we're minusing the whole value of h. So whatever is written here, just as the h itself, is going to be the h of our vertex. That means if we have something like this, y is equal to, let's say, 3 times x minus 4 squared plus 2, that means the h value is 4. And the k value equals 2, which means our vertex is located at 4, 2. However, if I wrote this, y is equal to 3 times x plus 4 squared plus 2, well, what is h now? If the original sign was negative, but now it's positive, that must mean that h is actually negative. H is negative 4, and k is equal to 2. Well, how do I know this? Because the only way you're going to get that positive sign is if we wrote it as this. 3 times x, if this is the original version, then it'd be minus 4 all squared. But what happens when you get a minus and a minus, and you multiply them? You get a plus. That's why the sign is switched. So if you want a simple way of looking at this, the sign of h is always the opposite of whatever we see inside of here. The sign of k always matches. So h's sign is always flipped, and k's sign always matches. So keep this in mind as we go forward. I'll leave that there as we go through the rest of the lesson. Okay. Now, these values, these h and k values, not only do they tell us the vertex, that basically also tells us, since our vertex is either our max or our min, that means that if our vertex is not at 0, 0, that means the whole quadratic relation has been moved somewhere else on the curve or somewhere else on the graph. So what does that mean? It means the values, the h and k values, will also be used to transform the graph of y is equal to x squared. Now I'm going to use another term that we've seen before, translate. What does translate mean? Not in the English language, but translate means to move. It's going to move the entire expression, the entire quadratic relation, either horizontally or vertically, depending on which one is which. Now, if we think about this, if h represents the x component of our vertex, that means h is going to control any horizontal movement. K represents the y value of our vertex. So that means k is going to control any vertical movement. Okay, so let's put this into practice and actually see what we mean by this. So let's graph out our parent relation, y is equal to x squared. We have the same old numbers that we always have. So negative 4 squared, or negative 2 squared, that's 4. Negative 1 squared, that's 1, 0, 1, and 4. Same old parent relation. Let's go graph it in there so we can see exactly what it looks like. Although we should all be experts at this one by now. Watch me make a mistake here just to prove a point. All right, so there is our parent relation. Fantastic. Now, let's graph this one. Y is equal to x squared plus 3. You're like, what? What are you talking about, Mr. Lane? How does that fit into this equation up here? Well, let's think about this. The square applies to the entire term inside the brackets. The a is the value outside of the square value, and the k is the value that's being added on here. So what does this actually look like? Well, this means that we have an a value of 1, because there's just a 1 sitting in front of there. So I can say, well, that's a 1. And now inside of here, I have x minus something. What is the value of h? There is no value h, so it's x minus 0 squared plus 3. That's what we've actually just drawn here. That's what this equation is in full vertex form. That means h has a value of 0 and k has a value of 3. That means our vertex should be at 0, 3. Well, let's find out. Let's see what that actually looks like. So let's substitute our value negative 2 inside of our equation. So negative 2 squared is 4. 4 plus 3 is 7. Negative 1 squared is 1. 1 plus 3 is 4. 0 squared is 0. Plus 3 is 3. 1 squared is 1 plus 3 is 4. And 2 squared is 4 plus 3 is 7. All right, we can see that there is a point of inflection here, a point of change. So let's graph this out and see what it looks like. So we have negative 2, 7. So negative 2 all the way up here at 7 right there. Okay. And we have a, you're probably looking at that and say, oh, it's been vertically stretched. But wait, a was 1. Well, let's keep graphing and let's see what it looks like. Now we have negative 1, 4. Negative 1, 4. And then we have 0, 3. And then 1, 4. And then 2, 7. Let's connect those dots. Let's label our curve. Y is equal to x squared. And this one is y is equal to x squared plus 3. That is a 3, I swear. And then over here we have our x-axis and we have our y-axis. Now look at those two curves. Does it look like our second curve, our second relation, our transformed relation, has been stretched or compressed? No, it looks exactly the same. It's just been moved. Remember we said how the vertex is 0, 3? There it is right there, 0, 3. So basically we just said, well, draw the exact same curve. There's y is equal to x squared, but let's shift it. Which way did we shift it? Well, this is the k value. Remember, k represents our y of our vertex. That means we shifted it vertically. Okay, let's go fill out our table and see how this lines up. So in our original parent relation, our coordinates of our vertex were still 0, 0. We're all experts at this now. The direction, well, it's opening up. Okay. The equation of the x-axis. Well, the equation of the x-axis is always x is equal to the x component of our vertex. X is equal to 0. Why is it the x component of our vertex? Remember, our vertex is hk. And the equation of the axis of symmetry is x is equal to h. Excellent. Okay, now let's fill out the column on the right. So where's our vertex now? Oh, it is no longer at 0, 0. Our vertex now, we can look at it right here, is at 0, 3. All right. Now, what direction is opening? Well, it's still opening up. And its axis of symmetry, it's still straight in the middle. So it's still x is equal to 0. None of that changed. But what actually changed? Well, the whole relation relative to the parent relation, what happened? Well, it vertically translated. There's that word right there, translate. Translate means to shift. Translated. And those are the words I want you to use. Vertically translated. How many units up? 3 units. In what direction? Up. So this tells me all the key information here. It translated 3 units up. That's the key data here. Let's highlight this information just so we can see it. So it translated 3 units up. That's the big key here. And we could easily see that just by looking at the k value. That k value has been shifted by 3. Okay, so let's carry on with the same information and let's move it forward down to the next page here. Give me a second to scroll down. There we go. So in the next page, I don't think I'm going to be able to fit it all on here, but we'll do what we can do. Well, we get the first one question at a time here. There we go. All right. So in this page, complete the table of values and graph each parabola. We can see that we have a very similar equation. We have the x squared, which means the h is 0, the a is 1, and we have a k of -8. Okay, let's see how this affects things. So we still have our parent relation. We still have the exact same values here, so we know that this is 4, 1, 0, 1, and 4. Over here, we have -2 squared, so that's 4. 4 minus 8, that's -4. Okay. -1 squared is 1. 1 minus 8 is -7. 0 squared is 0. Minus 8 is -8. Okay. And then 1 squared is 1 minus 8 is -7. And 2 squared minus 8 is -4. Okay. So let's graph it out. Let's put our parent relation on there first. We know our parent relation really, really well. It starts at 0, 0, then it goes 1, 1, and -1, 1, and then it goes 2, 4, and -2, 4. It's nice and symmetrical, so this one's nice and easy to draw. There's our y-axis, there's our x-axis. Let's label our curve. Y is equal to x squared. Okay, now let's put the next one in. -2, -4. -2 all the way down here. Okay. -1, -7. -1 all the way down here. And then 0, -8 right there. 1, -7. And 2, -4. Okay, let's draw our curve. There we go. Looks like the same curve again, except it's been shifted down. Y is equal to x squared minus 8. Okay. So let's put in our data. Our parent equation, vertex is still 0, 0. Nothing's changed. It's still opening up, and it still has an axis of symmetry, or line of symmetry, depending on what you want to call it. Axis of symmetry equals x equals 0. X is equal to h. Okay. How about this one? Coordinates of the vertex. Where's our vertex? It's way down here now. Now it's at 0, -8. That's because our k value was -8. Direction of opening. Well, it's still opening up. And the axis of symmetry, where it flips along the y-axis, well, that's still, where it flips symmetrically, that's still at x is equal to 0. Okay. So what changed this time? Well, this time, yeah, it vertically translated. Okay. The question is, how many units? 8 units. 8 units. I know this because the vertex has been shifted down 8 units. 8 units down. All right, down 8. Translate. That's all the data that we need to know there. Okay, let's switch it up a little bit. Now look at the equation. Things have changed a little bit. Now that minus 3 is inside the set of brackets. Remember our equation. Y is equal to a times x minus h all squared plus k. If we put this equation into this format, what are we looking at? We say y is equal to, what's the value of a? Well, a is 1. Okay. X minus 3, and we square that. But what's k? There is no k, so it's plus 0. What this tells us is that our a is equal to 1, our h is equal to 3, not negative 3. Remember, it's always, our h is equal to 3, positive there. It's always the opposite sign of what we see in there. Let me just erase that because that 3 is really difficult to read. Sorry about that. Minus 3, okay? And then our k is equal to 0. Well, since we know our h and k, we also know our vertex, which is just 3, 0, hk. Okay, so let's put all of that information that we got just from the equation onto the curve so we can actually see it. So let's graph our parent relation. We see we still have the same x values, so we're going to leave those exactly the way they are. So we end up with 4, 1, 0, 1, 4. Let's go graph that in. So we have 0 here. We got 1 and 2, 4. Oops, way up here. And 2, 2, 4. There's our parent relation. I don't know about that curve, but we'll deal with it. Okay. Now, this is our y is equal to x squared. All right, let's do the next one. Now we got to do some more mental math. So you'll notice that I've intentionally, by I mean whoever made these notes, I've intentionally changed the values of x this time. Now, you might probably try to consider why that's the case. You'll notice that the middle value in our original set of numbers represents our vertex, right? Now, I know for a fact, by looking at this, that the h value represents the middle of our relation, the vertex. So since I can see that h is a 3, I'm going to make that my middle number. And then I just surround it on both sides. So let's go take a look at what this actually creates. So if I substitute 1 for x, we have 1 minus 3. That's negative 2. Squared, that's 4. 2 minus 3, that's 1. 1 squared is 1. 3 minus 3 is 0. 0 squared is 0. 4 minus 3 is 1. 1 squared is 1. And 5 minus 3 is 2. 2 squared is 4. Aha. You might be like, hey, we got the exact same numbers. We did for our y values, but our x values are not the same anymore. So it's not the same equation. Things have changed. Let's go take a look. Let's go graph it in. So this says 1, 4. So 1, 4, way up here. 2, 1, right down here. 3, 0. 4, 1. And 5, 4. Now if we graph this in. Oh. Now we have x minus 3 all squared. Now, looking at this, it's the exact same relation, although my drawing is not very great, but it's the exact same relation. The only thing that's happened is it's been shifted to the side. And that's it. Remember, shift is another word for shift. The proper word for shift is just translate. So this is what we should see when we fill out our table down here. Let's go take a look. So our original vertex, our parent relation, y is equal to x squared. You're at 0, 0. I know your vertex is at 0, 0. You've never changed. I know you. Direction of opening, still opening up. A value is a positive number. Equation of axis of symmetry. Where is it? X is equal to h. X is equal to 0. Remember, this is hk, right? Over here we have hk, right? So what's our h? Well, our h in this equation is a 3. Right? We'll just look at it. Remember, it's the opposite sign of what we see beside it. So this is just a 3. What's the k value? There is no k value, so it's a 0. So 3, 0. We can also just look at the graph, and we can see that it's at 3, 0. That's the place where it changes direction. Direction of opening, it's still opening up, what about our axis of symmetry? For the first time in all of these lessons, our axis of symmetry is not x equal to 0. It's finally changed. Remember, axis of symmetry is always x is equal to h, but our h is a 3 now. So that means that the axis of symmetry is x is equal to 3. So what happened? Well, in this case, the h value, whereas before the k value is changing our verticality, the h value changes our horizontal aspect of our relation. So this time we get a horizontal translation. So horizontal translation right. So it moved to the right. Horizontal translation right 3 units. You can also write it 3 units right. That's okay. As long as it grammatically still makes sense, we're good. Okay, so we got a translation to the right 3 units long. Okay. So let's go do a couple more examples and then one more example and then we'll summarize everything together. Okay. A little bit of a shift there. There we go. Alrighty. So we're going to have one more. Now this is another change in our h value. So in this case, let's write out our value. So what is the value of a here? Well, a is a 1. What about our h value? H is always the number, which is 2. And the sign opposite that's beside it. Well, that's a plus, so this is going to be h is a negative 2. Okay? And what's the value of k? K, there is no k, so that means k is 0. So with that information, that means I also can get the vertex. The vertex is just hk, so that's just negative 2, 0. Okay, so let's go, now that we have all the information just by looking at the equation, this should make the graphing a lot easier and a lot easier to understand that we've done it right or wrong. So let's go take a look. So we have y is equal to x squared. All of our numbers are still the same. So we know that this is going to be 4, 1, 0, 1, and 4. Now I know my x value of my vertex is negative 2, so I made that my middle point, negative 2. So now I can go around it in both directions. So negative 4 plus 2, that's negative 2. Negative 2 squared is 4. Okay. Negative 3 plus 2, that's negative 1. Negative 1 squared is 1. Negative 2 plus 2, that's 0. 0 squared is 0. And then negative 1 plus 2 is 1 squared, which is 1. And 0 plus 2 is 2. 2 squared is 4. You're like, hey, they're the exact same numbers. Again, is it always going to be like that? No, it's not. It's absolutely not. It depends on the numbers that we choose for our x, but it also depends on the rest of the equation. If there's a k in here or anything else or an a value in there, they're not going to be nice and pretty like that. So we have to understand that these examples were created to demonstrate a point. Okay. Alrighty. So let's go label our graph and let's put in our equation. So we have our parent relation, which everybody can just quickly zoom in here now. There we go. Let's see if my graphing skills are improved. Oh, that one's not too bad. I don't mind that one. Okay. Now let's do the next one. Negative 4x and positive 4y. Negative 4, positive 4. Okay. And we have negative 3 right over here and 1. Then we have negative 2, 0. And negative 1, 1. Hey, they share a point. How about that? And 0, 4. 0, 4. We found a point of intersection for these two curves. Isn't that interesting? Oh, that was pretty atrocious. Anyways, let's label our graphs. Y is equal to x squared. This one over here is y is equal to x plus 2 squared. All right. So let's fill out our information. We should probably already know our information, but let's fill it out. Coordinates for the parent relation, 0, 0. HK. Okay. Direction of opening, still opening up. Equation of the axis of symmetry, x is equal to h, so x is equal to 0. Over here, now where's our vertex? Well, our vertex is at negative 2, 0. Well, we saw that up here when we did it before. Okay, negative 2, 0, HK, HK. It's still opening up. A is a 1. And the equation of the axis of symmetry, x is equal to h. So x is equal to negative 2. So what happened here? Well, we got a horizontal. It moved to the left. So horizontal. Oops. Can't spell. Horizontal translation. Which direction to go? It went left. How many units did it go? It went 2 units. Horizontal translation, 2 units. Okay? Again, you could have written that as horizontal translation, 2 units left. I don't really care as long as it's clear. Okay? So let's do a quick summary of everything we learned today. We know that the k value represents our vertical change. So that means if we have a positive k value, what direction does it take our whole relation? Well, it translates the entire parabola vertically up. How much? The absolute value of k. Okay? And when we have a negative k is less than 0, then this one is going to push the entire parabola downwards. How much? By the absolute value of k. All right. So the h is the same idea, but this time it's horizontal. So when we have a positive h, this is going to translate it to the right by the absolute value of h units. Okay. So this is going to translate. So in this example here, this is going to translate it to the right. In this case, our h is equal to 1. So it's going to change it. It's going to translate it to the right 1 unit. Whereas down here, h is equal to negative 1. Remember, it's always the opposite sign we see there. So this is a negative h. Okay? And this is always going to translate it to the left. Now, we always know that when we're looking at this, our vertex is simply going to be the value of hk. And this is going to be extremely important going forward when we get into word problems and other such examples. So there's lots and lots of practice work for today's lesson. So do your best to try and get through as much of that as possible, and it'll help you be really successful. All right. Thank you.